Chapter 4: Probability Trees and Conditional Expectation. In this chapter, we will look at expected value and expected variance. We will look at how to calculate expected value and expected variance. Then we'll look at probability trees and the conditional expectations. And then we look at the Bayes formula and how do we use the Bayes formula to update our probability estimate. The second section, which is expected value and variance. Suppose we want to forecast the revenue of a company called XYZ. You are an analyst and you believe that XYZ could have the following revenues. The revenue could be either $100 million or the revenue could be $120 million. So the expected revenue of XYZ company is 100 plus 120 divided by 2, which gives us 110. So you expect the revenue of XYZ company to be 110 million. You also want to forecast the profit of another company called as ABC. You expect the profit could either be $20 million, the profit could either be $35 million, or it could be 10 million. So the expected profit of company ABC is 20 plus 35 plus 10 divided by 3, which gives us the expected profit of $21.67 million. The point here is, implicitly we are assuming that each outcome have an equal chance of occurring. So in this case, when we are forecasting the revenue of XYZ, we expect that there is a 50% chance that the revenue could be 100, or there is a 50% chance that the revenue could be 120. Similarly, in case of company ABC, we expect that there is equal chance of any of the three profits being occurred. So there is a 33.33% chance of the profit being $20 million, 33.33% chance of the profit being $35 million, 33.33% chance of the profit being $10 million. Let me prove it to you. If you take 100 multiplied by the probability, so the probability is 50%, then add 120 and multiply it by the probability of 50%. You will get the expected revenue to be 110, which is the same as this. Similarly, in case of ABC, when we take 20 multiplied by 33.3%, we add 35 multiplied by 33.3%, and also for 10 million profit, we get the expected profit to be $21.67 million. So when we add all the observations and divided by the number of observation, we are implicitly assuming that each observation have an equal chance of occurring. But there could also be some scenarios where, say, there is 40% chance that the profit could be 20, or say there is 50% chance that the profit could be 35, and 10% chance of the profit being $10 million. Instead of equal probability, the probabilities could be different. So expected value of a random variable is the weighted average of the possible outcomes, where the weights are the probability. So in our case, the random variable was profit. So the expected value of profit is the weighted average of possible outcome. Various possible profits were $20 million, 35 and 10. And the probabilities were 40%, 50% and 10%. So the expected value of any random variable x is denoted by E bracket x, and the formula is probability of the outcome x1 occurring multiplied by the outcome x1. Similarly, probability of outcome x2 occurring multiplied by the outcome, which is x2. So in our case, the expected profit will be the first possible outcome, which is $20 million, and the probability of profit being $20 million is 40%. The second possible outcome, x2, is $35 million multiplied by 50%. And the third and the last possible outcome is 10 million multiplied by 10%. So we get the expected profit to be $26.5 million. Let us look at an example. As a part of your work as a banking industry analyst, you build models for forecasting the earnings per share of the banks you cover. So today you are studying the bank COP. In Exhibit 1, you have recorded a probability distribution for bank COP's EPS for the current fiscal year. So you have the following earnings per share for bank COP, and you are also given the probability of each earning per share. Sum of the all probability equal to 1, that is 100%. What is the expected value of bank COP's earnings per share for the current fiscal year? So the expected EPS equals to 2.6 multiplied by 15%, 2.45 multiplied by 45%, 2.20 multiplied by 24%, and $2 multiplied by 16%. We get the expected EPS to be $2.34 US. So just like we calculated the expected value, we can also calculate the expected variance of a random variable. So if you remember the formula of variance was S square equals to, we took the observation 1 and subtracted the sample mean and squared it. Then we took the observation 2, subtracted the sample mean and squared, and so on. We divided it by the number of observation. So again here, when we divide the sum of the squared deviation by the number of observation, we are implicitly assuming that there is equal probability of each deviation occurring. But we know that the probabilities may not be equal. So the probability of each squared deviation occurring depends on the probability of these outcomes occurring. So variance of a random variable is the weighted average of the squared deviation from the random variable's expected value, and the weights being the probability of each outcome. Variance of a random variable x is denoted as sigma square x or variance x, and this is the formula of variance, where we take the first possible outcome and subtract the expected value, and we then square it, and the probability of this deviation occurring, this squared deviation occurring, is the probability of this outcome occurring. Similarly, we take the second possible outcome and subtract the expected value and then square it, and the probability of this squared deviation occurring is the probability of this outcome occurring. So we multiply this squared deviation by the probability of this outcome occurring. So let us look at an example using the probability distribution of EPS from Exhibit 1. You want to measure the dispersion around your forecast. What are the variance and standard deviation of bank COP's earnings per share for current fiscal year? So if you remember, we had 4 possible outcomes for the earnings per share. They were $2.6 US, 2.45, 2.20 and 2. And the probabilities were 15%, 45%, 24% and 16%. So this is the random variable x, and these are x1, x2, x3 and x4. So based on this data, we calculated the expected value to be 2.34. Now let us calculate the variance. Variance equals to the first outcome, which is 2.6, minus the expected value of 2.34 squared, multiplied by the probability of this outcome occurring, which is 15%. Then we take the square deviation from the second outcome, which is 2.45 minus 2.34 squared, multiplied by 45%, plus 2.20 minus 2.34 squared, multiplied by 24%, plus 2 minus 2.34 squared, multiplied by 16%. So we get the variance to be 0.038785 US dollars squared. Now let us find out the standard deviation. The standard deviation equals to root of 0.038785 US dollars squared. So we get the standard deviation to be approximately 0.2 US dollars. So how do we interpret the standard deviation of 0.2 US dollars? We interpret it that on an average, we can expect the earnings per share to be 0.2 US dollars above the expected value or below the expected value. Section 3, Probability Trees and Conditional Expectation. A conditional expected value refers to expected value of a random variable x given a particular scenario has occurred, and a conditional expected value is denoted by E bracket x bar s. This bar represents given. So the expected value of x given that scenario has occurred. So continuing with our previous example of earnings per share. Earnings per share are influenced by the interest rate environment in the market. So there are three possible scenarios. The first scenario is that the interest rate might increase. The second scenario is that the interest rate could remain stable. And the third scenario is that the interest rate could decline. So say there is 20% chance of scenario 1 occurring, there is 45% chance of scenario 2 occurring, and there is 35% chance of scenario 3 occurring. So what is the expected value of earnings per share? So the expected value of earning per share equals to the expected value of earning per share given scenario 1 has occurred multiplied by the probability of scenario 1. In this case it is 20%, plus what could be the value of earnings per share, that is the expected value of earnings per share if scenario 2 has occurred multiplied by the probability of scenario 2, which is 45%, and the third expected value of earnings per share given scenario 3 has occurred multiplied by the probability of scenario 3. So the unconditional value, that is the expected value, can be calculated based on conditional values. So this is the formula where the expected value of a random variable x is the expected value of x given a particular scenario has occurred multiplied by the probability of that particular scenario occurring. So in our case, suppose the expected value of x, that is the expected value of earnings per share in an environment where interest rate increases is 8 and the probability of interest rate increases is 20%. And suppose the expected value of earning per share in an environment where interest rate is stable, suppose it is 10 and the probability of interest rate remaining stable is 45%, and the value of earnings per share if the interest rate decrease is say 9 and the probability that the interest rate could decline is 35%. So this is how you calculate the unconditional value based on the conditional expected value. It is also possible that under each scenario, the random variable x can have different values or outcome. So suppose we take scenario 1 where the interest rate increases. So if interest rate increases, the earnings per share could take 3 values. That is, there are 3 different possible outcomes of earnings per share. The earnings per share could either be $12, it could be $7, or it could be $15. So say the probability of earnings per share being 12, given that scenario 1 has occurred, is 50%. The probability of earning per share being $7, given scenario 1 has occurred, is 5%. And the probability of earning per share being $15, given the interest rate has increased, is 45%. Now I have assumed previously that the expected value of x given scenario 1 has occurred was 10. It was a random assumption. Now we are given with the following data. Now let us actually calculate what could be the value of x. That is, what could be the value of earnings per share if interest rate increases or if scenario 1 occurs. So we take 12, which is the first possible outcome, multiply it by the probability of that outcome occurring, which is 50%. Then we add 7 multiplied by 0.05, which is 5%. Then we take 15 multiplied by 45%. So the expected value of EPS given that scenario 1 has occurred is $13.1. Earlier I assumed it randomly, but given this information, we can say that EPS is 13.1 if scenario 1 occurs. And this is the formula where expected value of x given a particular scenario occurs is this. The probability of first outcome occurring given a particular scenario has occurred. So in our case it was 50% and the first outcome was 12. Similarly, probability of second outcome occurring given the particular scenario has already occurred. So it was 5% multiplied by 7. And the third possible outcome was 15, and the probability of that outcome occurring given the scenario has occurred. So the probability was 45% multiplied by 15. And we got this value to be 13.1. So this is how we calculate the conditional value of a random variable x under each scenario, then multiply it by the probability of each scenario occurring to get the unconditional value or the expected value of the random variable x. And this formula is referred to as the total probability rule. Let us look at an example and things will be more clear. The earnings of bank corps are interest rate sensitive, benefiting from a declining interest rate environment, meaning that the earnings are influenced by the interest rates. And if there is a declining interest rate environment, the earnings per share increases. So suppose there is a 60% probability that the bank corp will operate in a declining interest rate environment, and there is a 40% probability that it will operate in a stable interest rate environment. This implies that there is a 0% chance of bank corp operating in an increasing interest rate environment. So if a declining interest rate environment occurs, the probability that the earnings per share will be 2.60 is estimated to be 25%. And if a declining interest rate environment occurs, the probability that EPS will be 2.40 $2.45 is estimated to be 75%. So let us calculate the expected earning per share if we have a declining interest rate environment, which equals to 2.60, the first possible outcome, multiplied by the probability of this outcome occurring given that a declining interest rate environment has occurred, which is 25%. Adding the second possible outcome, which is 2.45 multiplied by 0.75. So the expected earnings per share, given that we are operating in a declining interest rate environment, is 2.4875. Now if a stable interest rate environment occurs, the probability that EPS will be 2.20 is estimated to be 60%, and the probability that EPS will be $2 is estimated to be 40%. So let us calculate the expected earnings per share given that we are operating in a stable interest rate environment. So we take 2.20 multiplied by 60% and $2 multiplied by 40%. So the expected earnings per share if we are already operating in a stable interest rate environment is $2.12. Now based on this information, let us calculate the expected earnings per share. This is the unconditional expected value, which equals to expected earnings per share if we are operating in a declining interest rate environment, which is 2.4875 multiplied by the probability that the bank corp will operate in a declining interest rate environment, which is 60%. You can refer it here. Then we add the earnings per share given a stable interest rate environment, which is 2.12 multiplied by the probability of a stable interest rate environment occurring, which is 40%. So the expected earnings per share equals to $2.34. So this is one way of calculating the unconditional expected value. There is also another way in which you can calculate the unconditional expected value. So this is the unconditional expected value, that is the expected value of earnings per share. So there are two possible scenarios. The first is that we could operate in a declining interest rate environment and it has a possibility of 60%. Or we could also operate in a stable interest rate environment and it has a probability of 40%. So if we are operating in a declining interest rate environment, there could be two possible outcomes. The EPS could be $2.60 or it could be $2.45, and the probability that the EPS will be $2.6 given that we are operating in a declining interest rate environment is 25%, and the probability of outcome being 2.45 is 75%. Similarly, in a stable interest rate environment, we have two possible outcomes. The EPS can either be $2.20 or it could be $2, and the probabilities are 60% and 40%. So now we can multiply this probability, that is the probability of EPS being 2.6 given a declining interest rate environment occurs. We can multiply this probability by the probability that there will be a declining interest rate environment, which is 60%, and we get the probability to be 50%. So there is a 15% chance that the expected value could be $2.6, full stop. This 15% is now an unconditional probability. Unlike this 25%, which was the conditional probability. This is an unconditional probability. Similarly, we can multiply the 0.75 by 0.6 and get 45%. This implies that there is a 45% chance that the earnings per share could be 2.45, full stop. There is no condition associated with this 45%. It is an unconditional probability. Similarly, we can multiply 0.6 by 40% and this by 40%, and we get 24% and 16%. Now we can multiply each of these conditional probability by the respective earnings. You multiply it by 2.6, 2.45, 2.2 and 2. We get $0.39. Then we get $1.1025. Then we get $0.5280 and then $0.3520. If we add all of them, we get the expected earning per share to be $2.34. So the answer using both the methods are the same. But I feel this method is more simple. So on your exam, if you get such question, you can do this method. This is less time consuming. I want you to solve this example and solve for all the 5 questions. So yes, if you have solved all the 5 questions, these are the answer. The answer to first question is $0.845. Answer to second question is $0.485. Answer to third question is $0.755. And this is how the probability tree diagram looks like. And the answer to fifth question is here. All these probabilities are the answer for the fifth question. Second example. I want you to solve this example and these are the 3 questions. So yes, if you have done all the 3 questions, these are the answer. Answer to question 1 is, this is 40%, this is 40%, this is 17% and 3% each. Now the answer to second question is the expected value of operating cost under the high growth scenario, which is $85.625, and the expected value of operating cost under the low growth scenario is 63.525, and the expected operating cost equals to 81.205. So just like we have conditional expected value, we also have conditional variance. Conditional variance refers to variance of a random variable x given a scenario S. You do not have any numericals on the conditional variance. You just need to know that just like conditional expected value, we also have conditional variance, and it is represented by sigma square x given a scenario. Fourth section, which is the Bayes formula and updating the probability estimates. We often have some viewpoints. We often start with some viewpoints based on our prior knowledge and prior experience when forecasting or finding out the probability of an event occurring. And this probability is referred to as the prior probability. The viewpoints that we had earlier may change as and when we confront any new information. So the prior probability we calculated was the probability before any new information has occurred. That's why it is referred to as the prior probability. Bayes formula is a method for updating this prior probability of an event as we confront any new information. And this is the Bayes formula, where the probability of an event given the new information equals to probability of the information given the event divided by the probability of information multiplied by the probability of event. This probability is the prior probability, that is the probability prior to any information. And we are finding out the updated probability or the posterior probability. Let us look at an example. Suppose you are an investor in the stock of DriveMed company, and DriveMed is preparing to release the last quarter's earnings per share result. So you as an investor is interested in knowing whether the last quarter's EPS exceeded, met or fell short of the consensus EPS estimate. Consensus EPS estimate means that what is the market expecting. So in a market we have various investors, various analysts. So on an average, what is the viewpoint or what is the expectation of the market? So suppose if the market believes that the EPS should be $15. So this is the consensus estimate. And you are interested in knowing whether the last quarter's EPS will be greater than $15 or will be exactly equals to $15 or will it be less than $15. So on the basis of your research, you write down the following probabilities for the events. So the probability of the EPS exceeding the consensus is 45%. The probability of EPS meeting the consensus is 30%. And the probability of EPS falling short of the consensus is 25%. So these are our prior probabilities. That is the probability we estimate prior to any information has occurred. This is the probability of the event occurring. The next day, DriveMed announces that it is expanding its factory capacity in Singapore and Ireland to meet its increased sales demand. So this is the new information that DriveMed is expanding its factory capacities. So you did the research and found out the following: that the probability of DriveMed expanding given the EPS exceeded the consensus is 75% and so on. So what are these? These are the probability of the information given the event has occurred. So given the new information that DriveMed is expanding, what is the probability that the last quarter's EPS exceeded the consensus EPS estimate? So we are required to find out the probability of the event given the new information, where the event is EPS exceeding the consensus and the new information is DriveMed is expanding. So we have the prior probabilities, the probability of the information given the event, and we are required to find out the probability of the last quarter's EPS exceeding the consensus given the new information that DriveMed is expanding. So we are required to find out the probability of the event occurring given the new information, which equals to probability of the information given the event divided by the probability of information multiplied by the probability of event or the prior probability. So the probability of DriveMed expanding given the EPS had exceeded the consensus is 75%, and the probability of EPS exceeding the consensus is 45%. And we are not explicitly given the probability of DriveMed expanding. This is the unconditional probability. We need to find out the probability of the information. So if you remember the total probability rule, which said that probability of a random variable equals to probability of the random variable given a scenario multiplied by the probability of the scenario 1 plus probability of the random variable given a second scenario multiplied by the probability of second scenario, and so on. So in this case, the random variable is the information or the DriveMed expansion. and we have three different scenarios. That is EPS exceeding the consensus, or EPS meeting the consensus, or EPS falling short of the consensus. So the probability of the new information given that the EPS is greater than consensus multiplied by probability of EPS greater than the consensus. Similarly, probability of the new information or Dreimed expansion given the EPS equals to the consensus multiplied by probability of EPS being equal to the consensus, and probability of the information given EPS is less than the consensus multiplied by probability of EPS being less than the consensus. So we multiply 0.75, which is the probability of Dreimed expanding given the EPS had exceeded the consensus, multiplied by 45% plus 0.2, that is 20%, multiplied by 30%, then plus 5% multiplied by 25%. So we get the unconditional probability of the information occurring as 41%. So we fill this information here, 0.41, and we get the updated probability as 82.3171%. So our prior probability, that is the probability of the EPS exceeding the consensus, EPS exceeding the consensus was 45%. But when we got the new information that Dreimed is expanding, so the probability increased to 82.3171%. It is pretty logical. When we did not know that there was any expansion, we estimated the probability to be only 45%. But when we got the news that Dreimed is expanding, it implies that the sale in the last quarter must be high. So the EPS also in the last quarter must be high, which increased the probability of EPS exceeding the consensus, which is reflected in this increased probability. I want you to solve these two questions by yourself, where you are required to update the probability that Dreimed's EPS met consensus given the new information, and also update the probability that Dreimed's EPS fell short of the consensus given the new information. So if you have solved the questions, the answer to question 2 is 14.63%, and answer to question 3 is 3.05%. Let's solve the following example. Jake Bronson is predicting the probability that consumer finance applicants who are granted credit will repay in a timely manner. So using the base formula, he has structured the problem as follows. So this is the base formula, where event, which is represented by A, is the timely repayment, and information represented by B is having a good credit report. So Bronson's estimate that the unconditional probability of receiving a timely payment is 90%. So probability of the event which is receiving timely payment is 90%. And the unconditional probability of having a good credit report is 80%. So probability of the information is 80%. And the probability of having a good credit report given that borrowers paid on time is 85%. So probability of the information given the event equals to 85%. So what is the probability that applicants with good credit report will repay in a timely manner? So we are required to find out the probability of timely repayment given that applicants have good credit report. This is probability of event given the information, which equals to probability of information given the event divided by probability of information multiplied by probability of event. Putting these values in the formula, we get the probability of timely repayment given a good credit report as 95.6%. So option C is the correct answer. Let us solve the second question. You have developed a set of criteria for evaluating distressed credits. So the companies that do not receive a passing score are classed as likely to go bankrupt within the next 12 months. So you gathered the following information when validating the criteria. So 40% of the companies to which the test is administered will go bankrupt within the next 12 months. So probability of not surviving is 40%. So the probability of a company surviving is 60%. And 55% of the companies to which the test is administered has passed the test. So probability of any company passing the test is 55%. So probability of a company failing the test is 45%. The probability that a company will pass the test, given that it will subsequently survive the next 12 months. That is, probability of a company passing the test, given it has survived, is 85%. So using the above information, we are required to calculate the following. What is the probability that a company will pass the test given it has not survived? So we are required to calculate probability of the information given the event. So using the total probability rule, the probability of a company passing the test equals to probability of company passing the test given it has survived multiplied by probability of company surviving plus probability of company passing the test given it has not survived multiplied by probability of company not surviving. So we are required to find out probability of company passing the test not survived. So this is what we need to figure out. So we know the probability of company passing, which is 55%. And the probability of company passing the test given that it has survived is 85%. Multiplied by probability of company surviving, which is 60%. Plus, let's keep this as x multiplied by probability of a company not surviving, which is 40%. So solving for x, we get 10%. So the probability of company passing the test, given that it's a non-survivor, is 10%. Second question, using the base formula, we are required to calculate probability that a company is surviving given it has passed the test. The probability of the event, which is surviving, given the company has passed the test, equals to probability of information given the event. So information is passing the test given the company has survived, divided by probability of the information, which is probability of a company passing the test multiplied by probability of surviving. So probability of company passing the test given it's a survivor is 85% divided by probability of passing, which is 55%, multiplied by probability of surviving, which is 60%. So we get the answer to be 92.27%. Let's look at the third question. What is the probability that a company is a non-survivor given that it fails the test? So we are required to calculate probability of not surviving given it has failed the test. So it is the probability of event given the information. So we need to use the base formula. Earlier we found out the probability of a company not surviving was 40%. Now given the new information that the company has failed the test, what is the probability of not surviving? So we need to update our probability, which equals to probability of failing the test given the company is non-survivor divided by probability of failing the test multiplied by probability of non-survivor. So we know the probability of not surviving is 40%, and we know the probability of failure is 45%. And we are required to find out probability of failing given non-survivor. We are not given the information directly, so using the total probability rule, where the probability of failure equals to probability of failure given the company is a survivor multiplied by probability of survivor plus probability of failure given the company is a non-survivor multiplied by the probability of non-survivor. So we are required to find out this term over here. So the probability of failing a test is 45%, and probability of failing the test given it's a survivor. This information is not given explicitly, but if you look carefully, we are given that if a company is a survivor, then there is 85% chance that it has passed the test. So can we say that if company is a survivor, then there is a 15% chance that it has failed the test. So this is the probability of company failing given that it's a survivor. So we get the answer as 15%. Then probability of a company surviving is 60%. Let's keep this as x multiplied by 40%. So solving for x, we get x as 90%. Now writing 90% over here, so we get the answer as 80%. So earlier we estimated that probability of a company not surviving is 40%. But when we got the new information that the company has failed the test, the probability has increased to 80% that the company is not a survivor. I want you to solve this question by yourself. This is pretty straightforward. And if you have solved the question, the correct answer is option B, 14.3%. So this question is again very similar to question 3. So if you have solved the question, the correct answer is option C, 3%.